this is
So they just got credit by
You add one and you add one here.
Oh,
and y.
Well, yeah, the wire.
Well,
Technically, starting at.
Okay.
That's good.
plus C. You would have gotten zeros on all.
Zero.
no.
I thought you were going. What?
We'll just do plus C on any of it.
Okay.
No, I
I
don't.
can do it later.
Yeah, we usually are. That's fun, actually.
Negative.
You don't have to do it for free by the quiz, but
Every single
if
time.
you're a good student, you do sit there.
Oh, really?
I want to do the warm up.
Oh.
But I don't have. I actually did one of those just.
That's negative.
Oh, then you did area one, that's the negative mark.
Yeah, it's.
My area one's right?
Ooh, looks like we're stuck.
Wait, what? I thought I did that.
Alright guys, let's go ahead and look at the first chart. It looks like everyone's on the area one.
Oh, I see.
So with the indefinite ones, again, we're just doing the basic rules that we have. So we know that we don't have a quotient rule for integrals. We don't have exactly a chain rule for integrals and haven't quite learned how to deal with that. So these are all examples that you have to rewrite. I will say for your quiz tomorrow, most of them you have to find a way to rewrite them. So these are three options we have for rewriting them. I chose these just to kind of show you some mistakes I often see. In that first one, a common mistake, I see people also pull the 5 up in the numerator, but we're only moving the x across. So then we know we can just integrate it, find the antiderivative, adding 1 to the exponent, bring across the one you have, and then divide by the new exponent. And then some of you will be very sad if you leave off your plus c tomorrow. So remember, for indefinite integrals, we have to have that constant there. Next one, 5x squared, same thing we did with derivatives. That is 25x squared, so you should have gotten 25 over 3x cubed plus c. And then this last one, until next week when we learn another process, you do want to make sure you distribute that out, and then you can just take the antiderivative of each part. And that's a 5. And then we have our plus c. Walking around, most people did that one. I did see some people leave off the plus c's. But then walking around, it looks like we're having issues starting this one off. So yesterday we talked about how the definite integral is the exact area, so not the approximate like a Riemann sum. We can use the definite integral to find the exact area. When we're talking about the exact area, we know it's going to be the integral from where the area starts to where the area ends of the function that you have. And walking around, most people see that this area is starting at 0. How can I figure out where that area is stopping at? Set it equal to 0. So that's basically an x-intercept. So I'm going to let you finish that one out if you haven't already. If you want to figure that out, that is just the x-intercept. I know normally when we're solving trig, we have an interval. So if I'm thinking about this one, this is going to be the first radian measure you come to after 0, basically. So go ahead and try that one, find the antiderivative, and finish that one out. And you don't have to simplify your answer, but since this will be a definite integral, your final answer should be a number. Also good just practice with solving trig equations.
Did you take a photo? Oh, no.
I can remember coming for a rectangle, this is like height.
What did you flip it?
I get it.
Hold on.
Oh. That's correct. He's not the smartest kid. Wasted.
Wow.
So again, there's my work if you're checking with yours. Again, we're just looking for the first gradient measure after 0 that we get the x-intercept. I rewrote this one, you can either write it as a cotangent or a tangent. And then once you find that x-intercept, find the antiderivative, and then evaluate. Some things I'll be picky about, all your integrals need to have that differential at the end of it, so like dx or d theta or dt, you can't leave it off. And then make sure you clearly show the antiderivative and then where you plugged in the top number minus the bottom number. Don't have to condense it or simplify it, you can leave it ugly as long as it's correct.
But you plug in the top one first, right?
Always, yeah. So there's my answer. Again, any equivalent answer I would also count as correct. What do we know that that answer should be though? Is the final answer going to be positive or negative? Positive. So we're above the x-axis, so we know that we have a positive area and we're moving forward. Matthew? Or no?
Oh.
Yeah.
So, are you gonna leave it as just
Remember, I don't want you, I always want you to evaluate for it. So like, I want to give you full credit until you evaluate it, just practice that. And how these are normally graded, just so you kind of know with a, like a partial credit. For this one, you would get points for the setup, so finding the correct limits of integration with the correct integrand. You would get some more points for the correct antiderivative, and then correct points for the final answer. That's kind of the points you want to show. Yeah.
So if we find the wrong upper limit.
If you found the wrong upper limit, I would give you some like carry through points. You wouldn't earn full credit, but I wouldn't mark it all the way complete. Yeah.
And like the format you said has to be like right also, like the way we write it.
I mean, this if you simplified it is fine, as long as it's still correct.
I'm talking about like with the bar and like the 5 bar.
The bar, yeah, I still want to see that notation, so like the antiderivative, and then with the vertical bar to show that we haven't evaluated it, I still want to see that. So for the rest of class, I know I would rather answer a lot of your individual questions, so just to kind of remind you where we are at. With your quiz tomorrow, it's focusing on Riemann sums and indefinite integrals. And when I say Riemann sums, remember that has 2 parts. Not only should you be able to find them, LRAM, RRAM, LRAM, and TSAM, but you also need to know when they're an overestimate and when they're an underestimate. When you take your quiz tomorrow, make sure you read the instructions carefully. For some of them, you don't have to find the approximation. I have the question phrase where you just tell me if you had found it, would it be an over or an under? And of course, we do that by looking at the intervals, whether it's increasing or decreasing, or the concavity of it. And I would just make sure you're comfortable with like the basic parent functions and know what those shapes are, which you are, so no big deal. And then the vast majority of the quiz is going to be with indefinite integrals. Make sure you review your trig ones coming straight from the derivative. Some of them you will have to rewrite, including using some trig identities. And then only the very last of the back page deals with definite integrals. One of them deals with the geometric one, so I give you a graph, and you can evaluate the definite integral by finding just the area. And then another one is just going to have you directly evaluate the definite integral using the first fundamental theorem of calculus. What's due tomorrow is I'm just going to be checking for homeworks 1 and 2. Homework 3, I will not check for until the day of the test. But if you finished homework 1 and 2, then like doing homework 3 is not going to hurt you. Like you're just going to have more practice with finding antiderivatives, plus it will make next week go a little bit easier. And then we come back, so you have the quiz Friday. Next week we're going to be doing something called U substitution, which will be the last topic we have for this introduction to integrals unit, and then your test is basically next Friday, so this will be a quick unit. Yeah,
The
Matt?
graph can be like what we just did here.
Say it again?
The graph can be like what we just did.
I'll probably give you the intervals, the limits. All right, guys, so I'm gonna go ahead and let you all get started. I'm gonna answer the questions for the people at home first, and then I'll walk around and answer the question or the. Yeah, go ahead. All right, guys, anyone at home have questions about anything yet? Makar, you can go first. I'm gonna put headphones in so I can hear you a little bit better.
Okay.